All right, so today we're going to be talking about different brain imaging tools. So we've talked about kind of the neural firing process of both the nervous and the endocrine systems. So we should have a general structure of understanding how the body communicates. But if we're in psychology, we have to be able to not just know how it communicates, but be able to know how we can study that and see the different parts of the brain, how they're functioning, and especially if they're functioning abnormally. So let's talk about the main ones that you'll need to know for AP psychology. So the first is the EEG, or electroencephalogram. This uses electrodes to read brain waves. Waves is the big word that you should be looking for there. The rest of the types of studies don't do this. They're more focused on like looking at structures or fluid in the brain. This is the only one that is studying the brain waves. So what they're looking for is that electrical activity that's similar, as we talked about, to that action potential that we've seen, the way the neuron is firing. So this is great for detecting problems with those communications we talked about within the nervous system. So it's very good for especially sleep studies. That'll be the main time that we talk about it in AP psychology. It'll be used to diagnose sleep disorders, the different types of sleep that you're in. For instance, dreaming, REM sleep, the waves look very different than when you're in deep sleep. So other things it can do, it can rule out or confirm seizures, epilepsy, head injuries, stroke, memory problems, things like that. It's also often also used in when patients are in a coma or during brain surgery to be able to keep track and make sure that the brain is functioning normally. So here is an image I just brought up. You can see the different types of sleep and how you and what the brain waves are looking like during that sleep. These are all totally normal. I know they all look radically different, but this is how sleep studies are performed when people who often have to sleep with these EEGs on, these goofy looking like hairnet things, and they'll sleep through the night at a research facility, and you'll be able to tell what stage of sleep they are in. So for people that have serious sleep problems, they'll often have to sleep with an EEG to make sure that they're going through the normal cycles of sleep. Others, the CT or CAT scan, computed tomography. So this is going to take X-ray photos of the brain. And so what this is mostly looking for is structural damage, brain damage, head injuries, major headaches, strokes, tumors, dizziness. All of these are things that the CAT scan can pick up on. So this also helps plan whenever cancer patients are trying to create a plan for what to do, where to attack with radiation. CT scan is used to set that up. A third is the MRI, or magnetic resonance imaging. This is also focused on brain structures, but it's looking specifically through fluid-filled areas in these ventricles. So this is using magnetic imaging. Okay, that's a big one you should be looking for, is like fluid-filled areas and magnetic field are kind of the biggies that you should see that show MRI in comparison to CAT scan. And they use radio waves as well to make this image. And so this is really useful for finding things that aren't supposed to be there, like tumors, bleeding, swelling, structural abnormalities. Inflammation can also show up on MRIs. So you can see what those look like. It's a little bit of it's definitely, you can see it's a bit of a superior image in comparison to the CT scan. And we'll talk about pros and cons a little bit, but this shows the different kind of those you see in the dark portions of the MRI. Those are the ventricles. Those are fluid-filled areas, and we know what the brain is supposed to look like, and we can tell when there are abnormalities or something that's not supposed to be there. So which is better for all of these? We should probably recognize pros and cons. For the CT scan, the pros are that it's very good at detecting cancer. It's definitely faster than the MRI, and it's always cheaper, right? It also is better for kids often because it's way more tolerant of movement. In an MRI, you have to stay totally still for an extended period of time in a very enclosed environment that's very loud. So CT scan is definitely better in that regard. But as a con, it does use radiation. The MRI, and on the other hand, gives very, very solid pictures, high resolution pictures. So it's even better at identifying abnormalities. It doesn't use radiation, right? which is a win, especially if people need multiple scans, right? If you just need one scan, oftentimes a CT scan will be fine, but when we don't want to expose people to radiation consistently. So the MRI can be better for that because it's not using x-rays. So the cons of the MRI are that it takes a while. It's a loud and noisy environment. It can be very scary for some people. And it's usually very expensive. Hospitals often don't have a plethora of MRIs. They only have one or a couple of these. So it means that it's extremely expensive. There can be a long wait to use them, and they're not going to be able to give these out to everyone. The PET scan is one of the final ones we'll look at. This is positron emission tomography. So this is looking only at brain activity. Okay, so it's not so much looking at the structure of the brain. The PET is looking at what parts of the brain are being used at what time. Okay, so the way it does that is it's studying the fuel consumption or glucose. Right, so what parts of your brain are burning glucose at this time? So what part of your brain is functioning? And this can see different things. This can also detect cancer, but it's going to be looking at what parts of the brain are not functioning when they should be functioning. So through the use of PET scans, we've been able to look at the brain and say when someone is doing, for instance, these things, while they're walking, seeing, hearing, while they're trying to process a math problem, or they're trying to remember things, different parts of their brain activate. And if we have people do those things and their brain doesn't do that, that shows an issue, right? That shows that there's a problem in that part of the brain. It can also detect Parkinson's disease, dementia. And so you're looking there for the different colors. It follows very much with like the warm to cool spectrum. The blue areas are not being used. The red areas are intensely being used. So those are burning the most fuel at the time. And as we said, you can see in there some like cognitive dysfunctions or problems. Black means that just like nothing is happening. And so you can see in the Alzheimer's disease, kind of advanced Alzheimer's, huge portions of the brain are just not functioning, not really doing anything at all. Finally, the functional MRI. This one is kind of a combination of the PET scan and the MRI, at least in the images that you're getting. So this one also is measuring brain activity, but it does that while looking at brain structures and functions. So it's combining. While the technology isn't exactly a combination of the two, it is ultimately the images you're getting are a combination of the MRI and the PET scan. So it evaluates for stroke, diseases, and it's often going to be used to guide different treatments when you're dealing with the brain. And it's good because it can do abnormalities often because of the combined image of PET and MRI that others cannot. Okay, so you can see another one here. You see the structure of the brain in the background, and then the orange areas being the areas that are functioning or being used at that time. Same thing, pros or cons, PET and fMRI. The difference is small between these, except for maybe price. The PET scan is very expensive. There aren't a lot of these nationally. I think there's like in the United States, there's this like less than 50 PET scanners, and so you often have to go to a pretty big name hospital. I know UNC does have a PET scanner, but you have to go to a big name hospital to get one of these. So it's a great scan. It's very effective. It gives you really useful information, but it's expensive and it's hard to find or access. So only if you really need one will you get one. The functional MRI does give good pictures, but it's very noisy and you have to be very still. So again, it's kind of the same problems as the MRI as well. So that is that. Told you this one would be quick. Next time we'll get into the structures of the brain going forward. So good work. Much love.